Hello everyone, and welcome to this example recording on analysis by inspection. We will be analyzing voltage sources. So this example requires us to determine the currents I1, I2, and I3, and we're going to be using the analysis by inspection method with voltage sources. So what does this method say? If you remember, it all continues from Ohm's law, where we say the voltage is equals to the current multiplied by resistance, and we then extend this to say that, well, the voltages V1, V2, and V3 will give us the resistance matrix. So R11, R12, R13, R21, R22, R23, R31, R32, and R33 multiplied by the current. And the current will be I1, I2, and I3. And these are the currents that we're looking for. Right. So now, what are the resistances R11 all the way to R33? We know that the resistances R11 would be the sum of the resistances that can be found in loop 1. So if we go around loop 1, we can see the sum would be 5 plus 4, which gives you 9 ohms. R22, same, the sum in loop 2, that will be 4 plus 1 plus 2. That will be 7 ohms. R33 will be the sum of the resistances in loop 3, which will be 5 plus 3 is 8 plus 1 is 9. And we also know that the diagonal entries are always positive in sign, so we know that will be positive, positive, and positive. And the non-diagonal entries are negative in sign. Right, so this is positive, positive, and positive. Now, what about the values for R12, which should be the same as R21? So this would be the sum of the resistances that are shared between loop 1 and loop 2. So loop 1, loop 2 has a 4 ohm that's shared, and it will be negative in sign, so that will be negative 4. Right, and then R13, which is equals to R31, will be the sum of resistances that is shared between loop 1 and loop 3. There is loop 1 and this is loop 3, that will be minus 5. And then finally, R23, which is equals to R32, will be the sum of resistances between loop 2 and loop 3, which is that are shared between loop 2 and loop 3, which is the 1 ohm resistor. Right, so we've got all our diagonal entries. The next thing is to determine the voltages. So how do we determine the voltages? We sum the voltages in each loop and we just add them to V1. So in loop 1, we're going to say KVL, negative 10 volts plus V1 gives you 0. Therefore, V1 is going to give you 10 volts. In loop 2, we're going to say positive 5 volts plus V2 gives you 0, which then tells us V2 is equals to negative 5 volts. And then in loop 3, we can see that there is no voltages in that loop. That tells us that V3 must give us 0. And we can then write the whole expression, which is V1, which is 10, V2 minus 5, V3, which is 0, equal to R11 will be 9, R12 is minus 4, R13 is minus 5, R21 is -4, R22 is 7, R23 is -1, R31 is -5, R31 is -5, R32 is -1, and R33 is 9. So we double check to make sure. So 1, 2, and 3, we know that these two should be the same. We know that 1, 3, and 3, 1 should be the same. We know that 2, 3, and 3, 2 should be the same. Right, and then we multiply this by the current I1, I2, and I3. And that's the expression which we can then solve using our calculator. So we've got there 3 equations with 3 unknowns. We're going to use option 2. So the first coefficients, 9, -4, -5, and 10. 9, -4, -5, and 10. The second coefficients, -4, 7, -1, and -5. The third coefficients, -5, -1, 9, and 0. Right, so if we double check everything, that's 4, that's 9, -4, -5, that's -4, 7, -1, -5, -1, and 9, and the answer matrix is 10, -5, and 0. Right, and if we solve for that, we get I1 as 2,08 amps. We get I2 as 0,65 amps. And we get I3 as 1,23 amps. Right, and this is the product of using analysis by inspection to determine the currents I1, I2, and I3. Thank you for watching this video and enjoy the course.